Only 3% of mammals stay with one partner for life. Not humans as a species, 3% of all mammal species on Earth. Wolves do it. Beavers do it. Some bats do it. And somehow, against every evolutionary incentive, so do we, at least most of the time, most of us, for most of our lives. That number should stop you. Because from a pure survival of the genes standpoint, monogamy makes almost no sense. If you're a male mammal, your genes spread fastest by mating with as many females as possible and moving on. If you're a female mammal, you often don't need a partner sticking around either. You just need enough resources to raise your young. So why did humans end up as one of the rare exceptions? The answer starts with something you'd never expect to matter: brain size. Human babies are born with skulls that are already pushing the limits of what the human pelvis can deliver. If we stayed in the womb as long as other primates relative to our brain development, we'd need to gestate for nearly 21 months instead of 9. Evolution solved that problem by kicking us out early, dangerously early. Human infants are born essentially unfinished. A baby chimpanzee can cling to its mother's fur within days. A human baby can't even hold up its own head. That means human infants require an enormous, sustained amount of care for years, not weeks. And that changes the math of survival completely. A mother trying to raise a helpless infant alone, in the middle of the Pleistocene, surrounded by predators, with no stable food source, has dramatically lower odds of that child surviving to adulthood. A mother with a partner who sticks around to hunt, defend, and share food roughly doubles the child's chances. This is called the paternal investment hypothesis, and it's one of the leading explanations for why pair bonding became so deeply wired into us. Monogamy, in other words, might not be romance. It might be a survival algorithm. But there's a second piece to this, and it's even stranger. Human ovulation is hidden. Most female mammals broadcast fertility loudly, through scent, swelling, or visible behavioral changes. Human females don't. Nobody, not even the woman herself without tracking it, can pinpoint the exact fertile window just by instinct. Anthropologists believe this concealment evolved specifically to keep a partner guessing, and therefore keep him close, all month, every month, rather than showing up only during a narrow fertile window like most other species. If ovulation were obvious, males could mate strategically and leave. Since it's hidden, sticking around becomes the safer bet for passing on genes at all. Your body may have literally evolved secrecy as a bonding mechanism. Some researchers even connect this to why humans are almost always sexually receptive, unlike most mammals who only mate during a narrow fertile season, since constant receptivity keeps a bond active year-round instead of just during a breeding window. Now here's where it gets even more interesting, because pair bonding isn't unique to humans, and studying the animals that do it gives us a shockingly precise look at what's happening inside your brain when you fall for someone. Prairie voles are small, unremarkable rodents, but they're one of the only other mammals that form lifelong pair bonds. Scientists compared them to a nearly identical species, meadow voles, who are promiscuous and never bond. The genetic difference driving this entirely different behavior comes down to receptor density for two specific chemicals, oxytocin and vasopressin. Prairie voles have far more receptors for these hormones in the reward centers of their brains. When researchers artificially boosted those same receptors in meadow voles, the promiscuous species, they started forming pair bonds too. One neurochemical switch changed their entire mating strategy. Humans run on the same two chemicals. Oxytocin floods your system during touch, intimacy, and childbirth. Vasopressin is linked to protective, territorial attachment, the instinct to guard and stay near a partner. When you feel that pull toward one specific person, that's not just an emotion. It's the same biochemical circuitry that evolution built into voles millions of years earlier and repurposed in us. Researcher Helen Fisher took this further and mapped human romantic attraction into 3 separate, overlapping brain systems, each with its own chemical signature. Lust runs on testosterone and estrogen, and it isn't picky. It evolved to motivate mating in general. Attraction is the intense, obsessive phase, driven by dopamine and norepinephrine, the same reward pathway triggered by cocaine, which is part of why early romantic love can feel euphoric and consuming. The reason relationships often shift from obsession to something steadier over time isn't a loss of love. It's your brain switching which chemical system is dominant, moving from a system built for finding a partner to one built for keeping one. There's a reason the obsessive phase never lasts, too. Studies looking at couples over time have found that the intense, dopamine-driven infatuation stage typically fades within 12 to 18 months. That's not a flaw in your relationship. Some researchers argue it's a built-in timer, just long enough for two people to become deeply attached, often long enough to conceive and get through a pregnancy, before the brain shifts from chasing a partner to keeping one. The chemistry that makes new love feel obsessive was never designed to last forever. It was designed to last exactly as long as it needed to. There's also a physical signature to attachment that most people never notice. Long-term couples tend to sync up in small, involuntary ways, matching breathing patterns and heart rates when they're close to each other, a phenomenon researchers call interpersonal physiological synchrony. It's tempting to imagine this as a holdover from a time when staying in sync with a partner meant moving and reacting together, back when separation from your group could be lethal, though that connection is speculation rather than something researchers have directly confirmed. But if monogamy is so deeply built into our biology, why does infidelity exist at all? And why has polygamy shown up across so much of human history? Cross-cultural anthropological surveys of human societies have found that the vast majority of recorded human societies have formally allowed polygamous marriage in some form. But when you look at actual lived behavior, not what was legally permitted, but what people actually did, most marriages in those same societies were still monogamous, simply because supporting multiple households required resources that only a small, wealthy minority ever had. So structurally, humans lean monogamous by default, and multiple partners have historically been the exception tied to wealth and power, not the evolutionary norm for most people. Which brings us back to where we started. Evolution didn't need you to fall for one person. It needed you to survive raising a child born helpless. So it hid your fertility to keep a partner close, wired your brain with it, and built a three-stage chemical system to carry you from a glance across a room to decades by someone's side. Falling in love was never just a feeling. It was a survival strategy.